A chemical bond is the force of attraction that holds two atoms together. As independent particles, atoms are at a relatively high potential energy. Most atoms are less stable existing by themselves than when they are combined. By bonding with each other, atoms decrease in potential energy, thereby creating more stable arrangements of matter.
Ionic bonds begin to form when an atom whose outermost energy level is almost empty transfers an electron to an atom whose outermost energy level is almost full. The two atoms are strongly attracted to one another and bond because this new situation changes the atoms to ions of opposite charge. Particles of opposite charge are attracted to each other.
Many atoms form covalent bonds. In covalent bonds, electrons are shared by both atoms. The first energy level in atoms can hold 2 electrons. By sharing electrons in a covalent bond, each hydrogen atom has a full outermost energy level. Water molecules are also held together with covalent bonds. Again, we see that covalent bonding gives each atom a full outermost energy level. The outermost energy level for hydrogen can hold 2 electrons. The outermost energy level for the oxygen can hold 8 electrons. In covalent bonds, the shared electrons move between the atoms that share them, forming a single electron cloud around both atoms. Comparing polar and nonpolar covalent bonds. In covalent bonds, atoms share electron pairs. If they share them equally, the covalent bond is nonpolar. If the electrons are more strongly attracted to one of the atoms, the covalent bond is polar. This diagram shows the relationship between the difference in electronegativity and the type of chemical bond between two atoms. The electronegativity difference between fluorine and cesium is 3.3. Because this is greater than 1.7, the bond is ionic. The fluorine atom has almost complete control of the electron, and the attraction between the two atoms is mostly electrical. The electronegativity difference between chlorine and hydrogen is 0.9. Because this is greater than 0.3 but less than 1.7, the bond is polar covalent. The chlorine atom has a greater attraction for the shared electron than the hydrogen atom. The electronegativity difference between hydrogen and hydrogen is 0. Because this is less than 0.3, the bond is nonpolar covalent, and the two atoms share the electron equally. The outer electrons in metals are able to move a lot more freely than electrons in nonmetals and metalloids. Partially empty energy levels offer multiple positions for any given electron. Since outer energy levels of adjacent atoms are relatively close together, electrons in metals can also move from one atom to another. The result is metallic bonding. The positive metal ions remain in relatively fixed positions, while the negative electrons are free to move about. This creates bonds extending through the metal in all directions and leads to many of the observed properties of metals.